I wanted to go over week 2 lab, and so I want to share the classroom. Okay, and so we are now in week 2, and in week 2, there is the week 2 overview, and you will find all the information that'll help you with this particular week's information. So the textbook, chapters 3 and 4, are very instrumental in helping you understand the materials. So make sure you read through those chapters. And there's also helpful practice problems for that. And then there's these 3 videos, one on chemical bonding, one on Vesper theory and molecular geometry and the Lewis dot structures. And so you want to go over that information. And this week, you'll learn how atoms share electrons in covalent bonds and exchange electrons in ionic bonds, forming the building blocks of various substances. These chemical interactions are essential to understanding the structure and behavior of different materials in the world around us. And so that is what we will be learning for this particular week. Also, you'll find in this week, we have our discussion forum, which is exploring the divine chemistry of God's creation. So make sure that you record your post there. And then the video lab presentation, that's what we're going to go over right now. You'll also have review number 2 and the quiz number 2. So I want to go over in this video the video lab presentation. Okay, and so here you have this overview. This lab requires you to perform an experiment using household items. These hand-on learning activities allow you to examine chemistry concepts through practical applications. Okay, and so we want to look at the actual lab as it comes up. Okay, I'm gonna go. All right, so when we're looking at this, let me go back to the beginning so we can get the overview. All right, so the overview, this is bonding in molecules and Lewis structures. So molecular compounds are formed by sharing electrons between nonmetal atoms. A useful theory for understanding the formation of molecular compounds, shapes of molecules, and several other properties is called a Lewis dot structure. We will explore the use of Lewis dot theory to generate structures of molecular compounds and to build 3D models in order to predict shapes and polarity of molecules. And so what you'll need for this particular lab are some marshmallows. The mini ones work better. And then some toothpicks and a marker, okay? And so if you look at the next page, this gives you your instructions, okay? So first of all, you're required to submit a 2 to 3 minute video of you completing a portion of the lab without assistance. You will be required to show and label with your name, the date, and the course information in the video to prove that you are completing the lab. If you do not submit the video, you may receive no credit on this assignment. And so this is only a portion of the lab, so you do not need to videotape you doing the entire lab. Just as long as you show a label. Last time for week 1, I said that if you put on a note card your name, the date, and the course information, meaning that this is week 2 lab on bonding and molecules and Lewis structures, hold up the card while you're talking and introduce yourself in the video and then start working on the lab. It just needs to be 2 to 3 minutes and you're going to submit that video. All right. But these is the procedures. So you're going to count valence electrons. And the valence electrons and that information is going to be in chapters 3 and 4 of your textbook. You'll find out more about valence electrons. But just to give you a heads up, if you look at the element group number, okay, which is located in the periodic table, that will tell you the number of valence electrons. So for example, H represents hydrogen that's in 1A or group 1, and so it has one valence electron. N is nitrogen. It has 5 valence electrons because it's in group 5. C is carbon. It has 4 valence electrons because it's in group 4. Okay, so do that with all the elements that you'll need for this particular chart. Okay, because you're going to go through the valence electrons because you're filling in this table. When you're doing the number of valence electrons, you want to add them all up. One thing to note that if it has a subscript, that means you take that subscript and multiply it by the number of valence electrons. So let's do this first one together. So C, carbon, is in group 4, and so it has 4 valence electrons. Hydrogen, like I said before, is in group 1. It has 1 valence electron, and there are 4 of them. So 4 times 1 is 4, plus the 4 from carbon, and so you would put an 8 here for the number of valence electrons. Okay, that's the total valence electrons. When you are looking at the molecular shape, okay, within your chapter 4, okay, I'm going to go to it on the screen. Let's see if it comes up. I probably have to move it so that I can get to it. Okay, I had a box there in the way. Okay, there we go. All right, in chapter 4, section 4.5, this gives you information about your molecular shapes, the Vesper theory, all of that information. And so it depends on the number of bonds as well as the number of lone pairs. So if we look at that first one, it looks like this, and I'm going to show it to you on the actual screen, but it looks like this because it has the central element, which in our case is carbon. It has the 4 hydrogen around it, and so that would have 4 bonds, and there's no dots around the central element, so there's no lone pairs. If you look at this next example, if it was 3 bonds and 2 lone pairs, that would be trigonal pyramid, but we have tetrahedral for our shape, okay? So let me go back so that you can see what that looks like. Okay, so if we go back, all right, so we have our carbon in the middle, we have our 4 hydrogen around it. So these toothpicks represent the number of bonds. So there's 4 bonds, and so the molecular shape would be tetrahedral. And so that's what you would put in that box, okay? This goes through and it explains how we do the different structures and then determining our molecular geometry. But remember, you're going to look at your textbook, section 4.5, and that'll give you that chart that lets you know, based on the structure, what that molecular geometry is, okay? But if you have any questions as you're going through this lab, make sure that you let me know before you submit the lab, okay? And so then it asks you to submit pictures of your different molecules. So the picture of the CH4, you want to take a picture and you want to drop it in here. And so there's a way to do that. You click on the image and then you can drag and drop it in here. Or if you click on this, then you can find the file where you save the image. Okay, if you take a picture with an iPhone, make sure that you change the picture because iPhone does its own type of formatting for pictures, and so you want to make sure that it is a format that is easily read. So you want to make sure you change it to a JPEG. Okay. All right. So then for number 3, you're going to submit your photo for the structure of H2O. Number 4, you want H3O plus. One thing I want to mention that you see some of these have charges on the actual compound. If it has a plus charge, then the number of valence electrons will be 1 less, okay? Whatever the plus number is, you're going to subtract that from your electrons, whatever the minus number is, you're going to add that to electrons. Because remember, if it is negative, that's the same sign as electrons. Electrons are negative. And so you will be adding to electrons if it's negative. If it's positive, you're subtracting from your total number of electrons. Okay, so I do want to point that out. And then for number 5, you're submitting your photo for N2. And then for NO3 minus, for CO2, for NH3, for HF, for SO4 2 minus, CCl4, and then finally for number 12, you are going to submit your video, okay? And then you want to make sure that you save and review your attempt. If you have questions though, do not save and review it because that's going to, you want to make sure that you've answered all of your questions before you turn this in, okay? So you want to make sure that you do that. And if you have questions, my information is located on the homepage. So let me go back. Excuse me. So if you see here on the side panel where it says welcome to chemistry, my information is here. This is my phone number. This is my email. So those 2 ways you can reach me. You can either call me or text me. I'll get back with you, or email me. I'll get back with you within 24 hours if you have a question. All right. So your work for this week is due on January 27th, which is a week from today. And remember, our due dates are 8 a.m., okay, with the exception of week 8. But if you have questions long before then, let me know. Generally, I check my email and my phone messages daily, with the exception of Sunday. Sunday is my Sabbath, and so I do not check email nor phone messages on that day. But any other day during the week, I do check. All right. So have a great day and enjoy doing this week's work. Bye bye.